Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Let's discuss about interference of waves. Now look at the waves. Okay, now let's look at this computer simulation. Okay, so I have two waves, okay, moving towards each other with the same amplitude. Okay, when they superpose, bila berjumpa, wave dua-dua ni berjumpa, the amplitude increases. Okay, that is what happen if the amplitude is the same. Okay, tengok kotak tu, amplitude is the same. So propose the total amplitude will double up. Okay. Okay, now we make the amplitude, one become positive, one becomes negative. So what happen when they superpose? Okay, they will cancel each other. Nampak? So becomes zero when they meet. Okay, this is another simulation showing the same thing. So we have two waves. Okay, one wave is the blue one, okay, with the same amplitude as the green one. Okay, they have the same amplitude. So okay, now I show them in slow motion. Look at the particle. Okay, now look at that. Okay, blue decreasing. Okay, blue decreasing, but the green one increasing. Okay, the red one is the total of them. Total of amplitude blue wave plus green wave. Okay, look at the total. Okay, now, okay, at the peak, okay, blue plus green. So we have the red one. So the high, we have the highest amplitude. Okay. Now, what happens if blue increases but green is decreasing? Okay, now look at the total. Total is zero. Okay, kenapa? They cancel out. So ini gives us the definition ataupun the principle of superposition. So from the simulation we can say that the principle of superposition states that when two waves overlap, okay, like this, the result displacement is the sum of the individual displacement of the two waves. Superposition tu bila kita tambahkan dua-dua ni, kita dapat resultant ataupun kita dapat hasil tambah. Itulah yang dimaksudkan hasil tambah apa? Hasil tambah kedua-duanya lah, kedua-dua wave tu. So itu yang dikatakan principle of superposition. Okay, now after we have watched the simulations, we have two questions. So which superposition produces a larger displacement? Okay, the answer is constructive interference. So this is constructive interference. Okay, the second question, which superposition produces zero displacement? It is, yes, it is destructive interference. So this is destructive interference. Okay, but constructive interference ni, it can be formed from two crests or okay, dua puncak ataupun dua lembangan atau trough. Okay, these are troughs. So two troughs combined also gives us constructive interference, but at the negative position. It again, the principle of superposition. So what is that? When two waves overlap, the resultant displacement is the sum of the individual displacement of the two waves. Okay, another important point is the term coherent. You need to know what is the meaning of coherent source of waves. So coherent source of waves means it has same frequency with the same phase difference. Okay, this is the top view of a ripple tank where we carry out an activity of interference wave of water. The two red dots are the two sources, okay, coherent sources. Okay, this is a simulation of the activity that we can carry out in the lab. So now we make the distance between the two coherent sources close to each other. So this is the pattern that we get. So let's say the solid green line represents crest, okay, and we cannot see the trough. So you can see from the two sources, they are overlap. Okay, then constructive and destructive interference can be observed. Okay, so we can see a pattern is formed. Okay, there are nodal lines and antinodal lines. Okay, what happens if we increase the distance between the two sources? Okay, so we see the pattern will be slightly different. Okay, this is another way of looking at the activity. So this is another simulation, but with the same aim. Yeah. So the two we have two sources, coherent sources. Okay, and we look at the pattern form from side view. Okay, so it is as if we see lines. Antinode lines. Okay, this line is called as antinode line. Okay, this line is formed from antinodes. Okay, we have a few antinodes. Okay, later we will see what are antinodes and what is the meaning of antinode line. Okay, and then in this activity, we measure the distance between the two consecutive antinodal lines. So this is the reading 7.2 cm. Okay, so if we carry out the experiment, we will increase the distance between the two coherent sources. Okay, and then we will look at the pattern. Now look at the pattern. Is there any change in the pattern? Okay, so there you can see the antinodal lines. Okay, is there any difference? Okay, now look at the distance between the two consecutive antinodal lines. So consecutive means berturutan, dia yang berturut. Sebab kita akan nampak banyak antinodal lines. Okay, so we want to measure the consecutive. So for example, this one we can see 4 antinodal lines. Okay, but we measure the distance between two consecutive, okay, ataupun successive ataupun bersebelahan antinodal lines. Okay, right. So antinodal lines is formed from antinodes. Okay, the next is activity of interference of light wave. Okay, zoom in. So this is the pattern you may see. Okay, so these are a few examples of patterns. Okay, this is wrong. Why? Can you see the difference between the top two and this one? Okay, if we recall, okay, this pattern is for that diffraction phenomena, not interference. Okay, you can see the difference. So this is interference, but the top two are the interference. Okay, next I want to give you an overview of how to carry out experiment of interference of sound waves. So this is the experimental setup. You can do it at home. Okay, you can just need two speakers and a sound generator. Okay, so here is the simulation. Okay, Right, in real life, you will not see the wave pattern, okay? Of course, you will not see the sound wave. Alright, when we carry out this activity at school or maybe at home, you must carry out the experiment in so you make a line. Okay, let's say here is your line, reference line. Okay, you draw the reference line along here. So you will walk along this line only. Okay, and then you will hear loud sound. Okay, and then the sound decreasing. And then when you walk further, you will hear another loud sound. Okay, loud, kuat, perlahan, kuat, perlahan, kuat, perlahan berturutan. Okay, tandakan. Okay, you will mark the loud sound region, kawasan ataupun the spot where you hear loud sound, you will make a mark, tandakan. Jadi bila dah tanda, you will see penggiliran lah, kuat perlahan, keluar perlahan, kuat perlahan. Jadi antara kuat dengan kuat tu, itu adalah antinode and antinode. So kita ukur jarak antara dua tanda yang awak dah tanda tadi tu. So contoh kat sini kita dapat 159 cm. So that is the distance between two consecutive antinodal lines. Okay. So ini saya tunjuk sikit lah. Sebenarnya sound wave kita tak nampak, but the particles, okay, they are reflection and compression. So look at the red particles. Okay, they move back and forth. Okay, alternatively, instead of you hear with your ears, you can use CRO or mobile digital CRO, which you can just download from Google Play. Okay, so and then you do the same steps. Okay, mark the high peak, low peak. High peak means high amplitude ataupun loud sound. Okay. Okay, there are a few examples of tuning fork activity to show interference. Okay, you can go to the link below to show very interesting activities related to tuning fork interference of sound wave. Okay. Okay, now here is the relationship between variables of interference of waves. Okay, so I have three patterns here. Okay. So the only difference between these three patterns is the distance between the coherent sources. Okay, so the distance is decreasing. Now, source 1, okay, gives us the red wavefronts. Okay, and then source 2 gives us the blue wavefronts. Okay, the solid line is the peak, and then the dotted line is the trough. So you can see red lines and blue lines sometimes intersect. Okay, so these intersections are antinodal points. So we have, okay, look at the yellow cross. So the yellow crosses showing us the antinodes point. Antinodes ni point. Okay. So point antinodes ni, the antinodes points. Okay, kita boleh buat line, and this line is what we call as antinodal line. Okay, when we have drawn a few antinodal lines, okay, right, so we can measure the distance between the two consecutive, remember the word consecutive? Okay, we will measure the distance between two consecutive antinodal lines. So that is X. Okay, so you need to understand these symbols. Okay, they are all distance. Cuma apa distance yang mana satu. Okay, So sebenarnya kita boleh juga buat untuk nodal points, nodal lines. Okay, but for this one, I just show you antinodes. Okay, the first symbol is lambda, which is the wavelength, and then A is the distance between two coherent sources, and then X is the distance between two consecutive nodal lines or antinodal lines, and D the distance between the source and the screen. So, if you have understood the phenomena of interference of waves, so we can study the applications of interference of waves in daily life.